Hey everyone, this is Matt with Learn Everything About Design, and in today's video we're kicking off a new small series where we're going to walk through the process of scanning some car parts, processing the scans, doing some alignment in quick surface, and then designing a new set of intakes that are going to replace a factory marker light. So through this process we're going to be using a handful of tools, and once we get to the design stage you'll be able to download the mesh bodies and be able to follow along if you want. But what we're going to be doing is using our Creality Scan Raptor Pro. We're also going to be using Quick Surface for the alignment, and then of course Autodesk Fusion to do the design. So there are a few things that we need to get out of the way before we get started on this. One, consider this a paid promotion for the scanning portion of this video. We will be using the Creality Raptor Pro. This was sent to us without any money changing hands, so anytime we do a video like this where we have sort of a required video, then make sure you just consider it a paid promotion. Now, I'm not coached on what to say. I wasn't told exactly what project I had to do, but it's always important just to remember that these are paid promotions. We are also a Creality affiliate, as well as a Quick Surface affiliate. So if you want to support the channel and you are looking to buy something, whether it's a printer or supplies or a scanner, you can check the description of the video. I'll put the information about our Creality affiliate in there, as well as information about our Quick Surface affiliate, which we'll talk about in the Quick Surface video as well. So all that out of the way, a couple of other sort of things that we need to check off the list. When we did our review video of the Creality Raptor Pro, there were a few things I said that were incorrect that I want to make sure that we correct that information. We had loads of comments, very helpful comments, so I do appreciate everybody that watched the video as well as provided some feedback. Nothing was really negative, everything was very positive and informative, so I always appreciate that. First things first, I mentioned that the Creality Raptor X, which is the handheld wireless version of it, was basically the same scanner just with some wireless accessories. That's not entirely true. So the X version has more cross laser lines. I think it's 34 for that version, it's 22 for this, and the base model just has parallel laser lines. The second thing I said that was incorrect is that the scan order is blue structure light, and it's actually NIR. It just happens to be a really good NIR scanner. So with that said, NIR in all three versions of the Raptor as well as the Otter, but from my experience, at least with this and the Otter as well as the Ferret, NIR in the Otter performs better than it does inside of the Raptor Pro. And from comments I'm seeing, I'm told that the NIR in the Pro kind of works better than the X and better than the base model. I haven't used either of those, so you'd have to do your own research there. A third thing that I mentioned that was unclear or incorrect is the resolution slider when we're doing our scanning. So that resolution slider is actually more indicative of how long it takes for the color to change on our preview. Now, if you're using an older version of Creality Scan like we used when we did the overview of the scanner, then your scan is going to be turning green as you get to that level. The new version, Creality Scan 4, it actually changes to a blue, not a green. But essentially what this means is if you set that resolution slider down to say 0.1, it's going to take longer for that scan preview to turn that color blue. And that simply means you've captured enough points to be able to fuse the points together with that resolution level. If you set it higher, say 0.5 or 1 millimeter, that doesn't necessarily mean that you can't still fuse it down smaller. It just means that you don't know when you've captured enough points to make that happen. So when we get to the scanning part, we're going to walk through that and we'll talk about what that means when we process the scan. And now, another full disclosure, I've recorded this video, I don't even know how many times at this point. The first time I did this, I forgot to turn the microphone on. That was last week sometime. And since then, there's a new version of Creality Scan, so I redid the scanning version of the video as well as the processing version. So what you'll notice along in the series is that the scans that we do in the video might be slightly different than the ones we actually end up using in Fusion and Quick Surface. It's all of the same parts, but you'll notice maybe different resolutions or different quality of scans. And that's just because slightly different software and slightly different settings when I went through the video a couple times. Okay, if you're still with me, let's talk about what we're doing so that way we can dive in. So on this car and on many different project cars that people have, we've tried to find ways that we can get air into either an airbox, directly into a turbo, or potentially brake ducting. Now, we've done videos on the channel before where we used a scan of an MX-5, it was specifically an MX-5 race car, trying to do a dual intake duct. What I'm doing here is I'm taking the factory fog light, driving light, and marker light out of the bumper. And what we're going to be doing is scanning the bumper with them installed. We're going to scan it without, and we're going to scan the bezel and the light itself. So the idea here is to get a final scan of the bumper without the light in it and the bezel in the correct place. So that way I have the mounting points from the light, and then I have the mounting points for the bezel to the light. And the idea here is that we're going to replace that with some intake ducts. Now, I don't have any hardware on this right now, but hopefully this will give you a good idea. So essentially what we're going to be doing is building this. And what this is going to be a set of intake ducts that will bolt in the factory location of the light, and then the bezel will screw onto it. So the bezel makes it look a bit more factory. It's divided, so the smaller side would be a brake duct. It's actually on the wheel side of the car. And then the larger one could be routed up to an airbox or cooling or some other location that could be used for direct air from the front of the car into the engine bay. So pretty common mod that people do. You can buy a lot of these types of things off the shelf for many different cars. For Starions, you can't. If you have an old car like this that doesn't really have big aftermarket support and never really has, then you pretty much have to design and make your own parts for most of the things. So we're going to walk through the process of how to do this, with the end goal being these 3D printed parts that we're going to install on the car. With all that said, let's go ahead and hop into scanning, so that way we can understand capturing the data before we ever get into the computer and start processing and building our parts. So let's go ahead and start scanning this stuff. Whenever we start the scan process, we're going to be basically inside whatever version of Creality Scan you're using, and just simply start a new project. I'm going to call this one Starion intake redo, again, because I've already filmed this. I'm going to have a second set of everything, so I just want to make sure that I understand it's the second version of it. One thing that we're going to notice from the video that I did when we were reviewing the scanner to now, the user interface of Creality Scan has changed wildly. So I think it's for the best. There are some new tools that I actually complained about in that. But what we're going to do is we're going to get started first with blue laser mode. The point cloud or global marker, if you're scanning small objects like these, you don't really need to capture global markers. It really comes into play when you're doing much larger objects because it really helps with the tracking. I haven't noticed any problems with tracking on stuff like this. So I'm just going to go ahead and capture the point clouds and the markers at the same time. Again, for the real-time resolution, this is going to be an indicator on screen. For this part, I'm actually going to set it lower. I'm going to put it all the way down to 0.1. We're going to be using cross laser line mode. It's a little bit quicker than parallel line mode at the expense of potentially getting a little bit more accuracy on these sharp parts. But for our purposes, I guess maybe I should explain what we're doing here. We're going to be using this bezel, which is the trim for this marker light, as basically a divider to create an intake duct. So this section here, theoretically, the duct will go back and it will go up to intake for the car, for the engine. This side here, the smaller side, will go down to brake ducting. So there's a set of these on both sides. Obviously, the other side's mirrored. So this could be dual intake for twin turbo, for example, brake duct on either side. With LED markers and things like that, we could still put marker lights or something in a custom designed bezel, but essentially what we want to do is we want to capture the bezel, the light, the bumper without it, and then we want to put them all back in the car and capture it with it. So I'm going to go ahead and set this up basically on a plate with some marker dots on it. It's sitting flat, but the part isn't flat. It is very much curved. And so we've got exclude flat base. I'm going to turn that on. Cross lines, color mapping is off, and we're going to select preview. So again, a big thing that has changed with this is now our preview camera is on the far right. So I want to make sure that the orientation works for me. So if I move it up, as it tracks the object, it moves the same direction that I would expect. Once I get it into a good height, so basically the light around the scanner on the play pause button is going to be green, and on the screen it'll say optimal. I'm going to hit play and just start to move it around. So remember that this is only going to work while it's capturing marker dots. The preview on the screen is going to kind of go from red to orange to green, and we just need to go back and forth until we get it to be green. Now remember, I set it on the lowest resolution, that 0.1, which means that it's going to take longer for it to turn green. If we had set it at a higher number, at like 0.5 or even 1 millimeter, we would probably be done by now, but we might not have all the resolution we need for this part. Do I need to get a really accurate scan of this part? Probably not. It probably doesn't need to be much more than an NIR scan on medium, but I think this is a good use case for us to play around with the laser scanning. Now you can see it's going from orange and it's starting to turn blue. So this is telling me that I need to scan this for quite a while to get this resolution. That's okay. So what we're going to do is on this side, we'll scan it until it turns green. And then on the other side, maybe we'll set that number a little bit higher. One thing that I've been really impressed with this Creality Raptor Pro is the ability for me to capture or to keep tracking on the markers at what I would consider fairly extreme angles. Most scanners are going to have trouble once we get down this far, and it seems to do a really good job. All right, so we're just going to keep going back and forth. Capture some data in here. Another thing to keep in mind is even if it doesn't all turn the color that we would expect, that doesn't mean that we can't just finish the scan. If we want to fuse these points at, say, 0.5 millimeter instead of 0.1, we might have already captured enough that we could finish this up. I'm going to keep going until everything turns blue. If you're using Creality version 3.5.6 or whatever the last one was, that scan went from red to green. It looks like this one here is going to stay blue. Let's go ahead and just move that back and forth. All right, so we get a little bit farther away. So maybe in the video, we'll just speed this part up. So again, remember, as we're scanning this in Creality version 4, we are going to be going from that sort of pink, red, orange to this blue color. This blue color is going to be our final color. If you're using an older version of Creality Scan, it would be turning green. So it would go from basically that red, pink, green color. And here it looks like with this new version of Creality, we're going to be going to a blue color. So I really want to make sure everything I'm interested in has this blue color on it. With features like these counterbores and recesses, those are actually going to be really tricky. And the reason they're tricky is because both depth cameras need to be able to see inside of it. And that's just not always possible. So for example, if we go this way, we might have a better chance of getting into those recesses. I kind of tilt it this way a bit. But in reality, those are going to be very difficult. The parallel laser line mode might do better than the cross laser line mode in that case. So I'm just going to kind of spend a little bit of time working back and forth in there. And then the other thing I want to do, because I need to align multiple scans, this is a thin part and I want to get the front and the back. I need to go over to the side and at the very least get some of this to turn blue where these casting ribs are. That way when I go to merge multiple scans together, I'll have enough data that it can actually do an alignment, whether I have to manually pick parts or whether it can just do it on its own. Just want to make sure we get that. The best quality scan is going to be if you're perpendicular to the surface you're scanning. In reality, that's not always possible. Like, for example, there's no way I can get perpendicular to that bottom section and still track the markers. So I'm just going to do the best I can, knowing that I'm going to flip it over and scan from the other side. All right, so I think I got enough down there. Come over to this side. There's a couple ribs over here. Just going to go back and forth, try to get it a little bit. Remember, with laser scanning, you only are capturing or bringing points back in wherever the laser lines are. So let's go ahead and just move that back and forth. And then this one area here looks like I didn't do a great job with. Kind of move back and forth. And again, getting into those recesses is going to be pretty tricky. I'm going to go ahead and do what I can. Those holes, basically the way this thing works is there are 2 mounting holes that mount it to the light, and then the light has 3 mounting holes to mount to the car. The 2 mounting holes from the bezel are going to mount to our new part, our intake duct, and then the 3 mounting holes on that are going to be to put the ducts on the car. So let's just take a quick look. I think we got everything we need. So what I'm going to do is complete that one and then create a new scan. So here for the resolution, I'm going to kick this up to 0.5 and turn on my preview. Once again, I need to rotate this 3 times. We're going to flip this over. Get to the optimal section and then start scanning. So now that it's on 0.5 resolution instead of 0.1, it is scanning quite a bit quicker. Not quicker in the sense that we're getting more frames per second, but quicker in the fact that it's turning blue on the screen much quicker. So there are already sections in that little recess area that are already blue. You'll also notice that we're picking up a bit more noise. So in the upper left-hand corner, the plate that the markers are on is shiny, which does on its own cause a bit more noise. But it is important to note that it is going quicker. But again, the main reason for that is because it's looking at the distance between the points. And before we had it set to 0.1, so it just needed to scan for longer to be able to capture that. Here it's set to 0.5. So it's much happier quite a bit sooner. I'm just going to do my best to get all the way around. This backside is also black. So the outside is obviously color matched to the car. So this is a cast aluminum piece. And this side is just kind of a black primer, I would assume. And then in that recess there, I need to make sure that I make the scanner parallel with it. Again, because both depth cameras need to be able to see inside there. And I think that looks okay. So obviously that happened quite a bit quicker. I'm going to select complete and zoom in. Again, just a bit more noise. It doesn't look great. Part of that is going to be fixed when we go to process it. I'm going to go ahead and do another scan. I'm going to set it again down to 0.1. And I want to set this thing up a bit higher so I have a better angle at it. Rotate the IR camera. Nope. Yeah, here we go. All right. Also, it is really, really humid in this garage, so I don't want to spend any more time in here than I have to. All right, so you can see when it was set to 0.5, we already had some areas that had turned blue. Here, it is taking a good bit longer. And again, it just comes down to that value is looking at the distance between points. So we're only capturing it where these laser lines are. And if we're looking at capturing at least 0.1 millimeters between points, it needs a lot more. If we're looking at 0.5, that is quite a bit fewer points for the overall object. So it just happens a bit quicker. And once again, we could stop here we have enough data. We don't need to make the entire thing turn blue. We would still be able to process it, maybe just not down to 0.1 millimeters. But just since we're here, I'm going to go ahead and just take my time and capture everything. What I found, again, because this is the second time I'm doing this, what I found is that capturing more is better. So a couple extra scans, you know, it might take you an extra 20 minutes, but having to come back, set everything up, takes a good bit of time. So what I found is when I scanned everything, I processed everything, when I went into Quick Surface to start to align it, it was more difficult than I had planned. And what I mean by that is I was having trouble aligning the bezel to the light and the light to the bumper. So what I ended up doing was coming back down here, putting the bezel, the light back on the car and scanning that in NIR large mode so that I had one scan I could align to a coordinate system, and then I used that scan to align everything else to, and it made the job a whole lot easier. All right, so the main thing again I'm doing, because we scan the top and the bottom and this is a thin part, I'm just trying to get a good reference on this side. Really the biggest thing for this part from a design standpoint is actually the backside. In reality, I need to know where the mounting bosses are so that they can attach to the new piece that we're designing. And it is also helpful because the ducting is going to be on the back side of this. So we need to know where the screw bosses are, we need to know where features are, and then we will be able to design our part. I'm not going to get everything blue on this, but just make sure that the corners are nice and clean. And then maybe spend a little bit of time capturing some more points on the side here. I tried to make sure that I'm somewhere between the optimal and good. This is the green and sort of the teal color. If you get too far away, the points tend to get a bit messy. So just remember that both depth cameras need to see what you're scanning. If you just get one, you know, so if you're off the edge of the part or only one can see down into that recess, you're not going to get anything back out of it. And then maybe I'll come back over here, capture a little bit over there. So what I'm noticing between Creality 3.x, the last version of this, and the Creality Scan 4, the preview seems to be more responsive, but I think what they've done is they have added more colors to the spectrum in terms of changing on the screen. So it feels like it's taking longer to scan. So basically this setup on 0.1, scanning the same part on the older version felt like it was faster. And my guess is that we're capturing more points and we're getting a higher quality scan with this version. I won't know that until we actually process it, but I feel like that's the case. So I'm going to go ahead and complete that one. And we'll call those good. And in the same project, I'm going to go ahead and do a new scan. For this light, there's not a great use case for laser scanning this. It's glass on the front, and that's going to be problematic. It is pretty dirty, which I think is helpful in this case, but I want to at least give it a shot. So what I'm going to do is I'm going to set this resolution again higher, maybe not all the way to 1, but 0.75, and we'll do preview. Again, have to rotate this a couple times. I need to be able to see the markers and then get started. All right. Not sure exactly what I hit, but the preview disappeared from the screen. And I don't know why. Press it again. Okay. Well, I don't know. I hit some button and it disappeared. Maybe it's because of the size of the object, but go to the top. So the problem with this on laser mode is I only have a couple marker dots on the lenses, and the only reason I had that was from scanning the bumper in the front of this car. So it was never really meant to be there to scan the light itself. So it's not quite enough, but maybe I can get a good scan for where the mounting points are. That's really all we're concerned with. I don't think it's going to work though. So let's go ahead and stop it. We'll complete that. We'll do a new scan. I want to, so I need the back of this. I'm going to do an NIR scan in infrared in medium, flat base removal. And let's rotate this around. Okay, so again, now what we're doing is feature-based. So I don't care about the markers. I just need to make sure that I have enough unique features on the part. So what we're going to do is see if we can't roll around the side. And the back side of this, the mounting points are actually more important than the front side because that's where our new part is going to mount to the car. So I'm going to go ahead and roll over here. Again, the preview all looks green, so that's probably good enough. I'm going to go this way, again, because both depth cameras need to be able to see where we're looking. Even when we're not in laser mode, even when we're in NIR mode, that's still true. If both depth cameras can't see where you're scanning, it's not going to be able to, basically it takes away its depth perception. So that looks pretty good. Let's go ahead and complete that. I also want to get an NIR scan of the front, so that way I can actually get these front mounting points. So I'm going to do another one, new scan, same settings, turn preview on. All right. So too far away, let's get closer. All right, it is not happy. So what I'm gonna do is trash that. And we'll try again. So I'm gonna start from the top and see if I can't roll to the front. So I don't really care about the lens. What I care about is the mounting points. I did have that laser scan of the front. I can align a laser scan and an NIR scan. But really all I care about is trying to get the top and again the front. All right, pause. There we go. We won't know what that looks like until we process it and go ahead and complete. All right. I could do a couple more scans for that. You know, as I said, I've already scanned all this stuff. I have the scans. So I think what I'm going to move on to is doing the bumper without everything, and then we should have all the information we need. So let's go ahead and reset up on the bumper. All right, so for the bumper, we're going to do a large NIR scan. And the main reason for this, for the bumper, and I think, is this going to be right? Let's go ahead and rotate. All right, so the main thing for the bumper is with the large NIR scan, it's going to have enough features so that it is able to align it. You know, these cars don't have a lot of unique features on them, so we need to be able to grab like the bottom edge of the pop-up and down to the corner of the air dam, maybe up around the corner there. That's pretty much all we need. The only other thing I would say is I've got the license plate holder here. And when I tried to go over there, you can see that I lost tracking. So what I'm gonna do is I'm gonna undo a couple times till I get back before I lost the tracking. And basically what happens is, let's go to here. Basically, once you get past a feature like this is so similar that it has trouble tracking. So what we want to do is get back to green. I'll start the scan again. You can see that, it just kind of lost its tracking. So what I'm going to do is I'm going to Undo. I already have everything I need, so I don't really need much more. I'm gonna complete, and then I'm gonna toss these in. Again, because I know that I need them, I don't need to screw them in. They sit basically how they are, and we'll get a new scan. All the same settings. And then, all right, so now what this scan is going to be used for is it's going to be a starting point reference. We can align this to a coordinate system, and I'll see if I can't get that, yeah, a little bit of that tag bracket. That'll help us with alignment. But basically what we're going to do is we're going to use this to help align the light, and we're going to use it to help align the bezel. All right, that's pretty much all we need. So preview looks good enough for what we're doing. Let's probably get some more under here. Go back to where it's green. See if it can find it. There it goes. All right, I'm just going to try to roll under here where the air dam is, see if I can fill in some of that. I don't need it, but it just bothers me if it's missing. And then we'll complete. All right, so the next part of this process is for us to take these scans and start to process them. I could process them here in the garage on the laptop, but it's hot and humid in here. And also I prefer to work with a mouse and dual screens and stuff like that. So I'm gonna take this back up and work on it on the desktop. And then we're gonna go ahead and process all these scans. Now, remember, when you have a scanning setup, when you're capturing data, it's always best to capture more than you need. I'm not too worried about that here, again, because I've already captured everything I need, designed the parts, and they're printing right now. So I know I don't need more scan data, but with anything like this, it's always a good idea to just capture a couple of extra scans. If you're not sure about it, then process, try to merge it before you undo all of your setup, and then you can capture anything extra you need. But for me, I know that I need the backside of the light. That's going to be the important mounting locations. I've also got them from the bumper scan. The large NIR mode doesn't have quite the accuracy or the resolution needed to do things like a section sketch of the mesh, but it's close enough for what we need for a 3D printed duct that's going to go in here. So if you need that data, you can do a small or a medium NIR scan of the bumper, or you can put marker dots on it and do a laser scan. It's a bit overkill for this. I have marker dots on it, but not nearly enough to make that happen. So capture the back of the light, so we've got the mounting points to the car, capture the front a little bit, so we've got the mounting points of the bezel to that, and then I can use the scan where they're all already on the car. I can align that scan to a coordinate system. I can then put the bezel in the right place and the version without the lights in place. So that way I've got the bezel as the front piece, and I've got the bumper with the openings and everything on the inside as the back piece. So now that we have that, let's go ahead and hop over and start to process this. All right, so now that we're at the desktop, we are gonna go ahead and process the scans that we captured in the garage. So again, we're using Creality Scan 4. So this is a recent update. It looks different than 3 did. The UI has changed. Most of the tools are the same, but there have actually been some additions, some potential things that I actually felt needed to be updated have changed. So for example, the select through option, we can actually toggle that back and forth. Things like that have changed. We'll go over all that, but the first thing that we want to do is we want to focus on processing our scans. So this was our first scan with the cross lasers, and we can see the preview on the screen looks pretty good. The second scan that we had was the backside, and we did that with a 0.5 resolution. So you can see the number of points we have is 835,000. And if we go back to the original scan, let's go ahead and hide this one. Actually, the original scan 790. The second scan is only 45,000 points, so quite a bit different between those two. The third scan that we did was, again, just on the back side,
looking at getting more information on the top so we could potentially align those 3 scans. So let's go ahead and let's work with these 3 points first and generate a model from here, because if we can do that, we can work with any of the other scans. But learning how to process each of these and then going on to merge them together is going to be important. So we're in the process section here, but there are 3 sections here. We've got scan, process, and calibrate. In order to turn the raw data, so let's go ahead and turn the markers off. In order to turn the raw data into a point cloud that eventually gets turned into a mesh, what we need to do is we need to go to Fusion. Now, this is an Autodesk Fusion. This is the term of fusing the raw points together into a more structured point cloud. So if we zoom all the way in, what we see here is actually a graphical preview of the data that we captured. It's not actually the points. It does give us a pretty good idea of the quality that we captured, but it's not the true points. So what we do is we go to Fusion, and you can see here there's a standard option and there is a fast option. So this has been a new change for Creality Scan 4. We didn't really have the same sort of graphical information to help us. The resolution value, again, we captured at 0.1 millimeters, and we can kick this all the way down to 0.07. This number is going to change depending on the number of points that you have. So sometimes it could go all the way down to 0.05. In this case, we need to think about what we need out of this data. So I'm going to do this first one at 0.1. And then we've got a point cloud confidence. So what this is going to do is this is going to basically look at the noise level in the points, and the higher confidence that we set. So if we set this thing up to 100%, it's going to keep all of the noise, so the highs and lows. So this point cloud confidence is really more of a smoothing value. So if we keep it all the way up, we're not going to have any smoothing. If we slide it down, we're going to have more aggressive smoothing. Remove markers, this is typically important. However, we don't have any markers on our part, so I'm going to turn that off. And then we've got this ultra detail section. So this was a checkbox in the last version of Creality Scan. So what this does is this allows you to set it lower. One thing that we want to make sort of note of is in the bottom right-hand corner, we've got the RAM available. So this desktop I'm on only has 32 gigs of RAM. The amount available is right around 12.8. So we could chew that up if we're trying to do a point cloud at 0.1 with ultra high detail. We could certainly eat all that up. So I'm going to leave that off, and I'm going to do the resolution at 0.1 and select apply. So now what happens here is it's going to go through and take a look at all of the raw data that we captured, which we're not actually looking at again. We're looking at a graphical preview of the data that we captured. So it's going to go through that process and turn it into an actual true point cloud. And the reason for this is because if you think about the points coming in from a cross laser line, anywhere the laser line was, it's going to bring points back. And you're eventually going to go over, basically directly over points that you've already captured. And so what that means is when we come to this stage, we may have a bunch of points scattered all over the place, and then we also may have a bunch of points really close together. And if they're really close together, within 0.1 millimeters, because that's the resolution we set, they'll be merged together. So if we set that value higher, let's say 1 millimeter, any points that are within 1 millimeter of each other end up getting fused into a single point. So that ends up theoretically leaving us with a pretty well structured grid of points that are equidistant apart at 0.1 millimeters or 1 or whatever you set your resolution to. So that's the general process, and that's why we tend to capture more data than we need, because we can always reduce and pull that out later. So we could go ahead and refuse this with a much higher number and see if it will give us the resolution we need. Now, even though it eats up the memory, I personally prefer to have a higher number of points that I can always reduce downstream at the mesh level. So processing that out at the mesh, taking a 2 million triangle mesh down to 500,000 triangles is easy to retain that data. It's much harder if we remove the data at the start. All right. So one thing that we're going to see here, and you're going to notice this on the screen, is we can actually see those cross laser lines, and you can kind of tell based on anything that's kind of happening here. These were all those cross laser lines, and that's the result that we're going to get out of this. And you can kind of see we didn't Didn't really capture anything in there. That's okay because we've got the location of it right there. But that's the raw data. If I zoom all the way in, I don't know if Creality 4 is going to let me see it, but now it's still a graphical preview. Basically what we have is a flat triangle, or I mean a flat square that's connected by 4 points. So the larger the resolution setting, the bigger those little squares would be. Now that this is a mesh, or a point, I'm sorry, let's go ahead and go to this one. The next thing we need to do is repeat that process with this one. Now, remember the resolution on this one, we set much higher at the scan level. So what I'm going to do is I'm going to set this higher at 0.5 because that's where we had it, and we'll apply it. So what you'll notice is that this will go quite a bit quicker than processing, hundreds of thousands of points down to a 0.1 millimeter resolution. Doing just 50,000 points to a 0.5 millimeter resolution goes quicker. And if we zoom in, again, we just have a preview. You can see that we've got basically a bunch of these squares. Now, there will be some areas where we're missing data. So for example, these two squares here, in reality, we would love for them to be in a pretty well organized structure, but you can see they're shifted a little bit, and that's just based on the data that we had. When we zoom out, we can't tell, but when you zoom way in, you can kind of get an idea of that. All right, now we're going to go to scan 3, and this one has sort of this extra little bit here. Now what we can do at this stage is we need to hold down Shift and draw around that, and then just hit delete to get rid of it. All right. So now we want to say okay for that deletion, and then we want to process this. So this one was captured a bit tighter. You can see at the bottom it says 0.1 millimeter. Point cloud confidence still set the same. Don't need to worry about remove markers because there aren't any on the part. And we're going to use the resolution somewhere in between, 0.35. It gives us that 0.35 based on the points that we captured, the size of the point cloud, the raw data, the number of frames that we captured, and it'll kind of recommend what you should do from there. But again, if you captured it at 0.1 and you're confident that you got enough, the model turned completely blue in Creality 4, or if you're using the older version, completely green, and you're confident that you have enough points to hit that resolution, then you can use that lower number. What's going to happen is if there aren't points close enough together to fuse them, you're going to end up with holes in the data. It'll filter out some of that noise. So as we're looking at this preview here, on the right-hand side, let's go ahead and rotate this around. On the right-hand side, there was some noisy mesh in this area, and it's completely gone. And the same thing is true if you've got, areas underneath these bosses, a little bit noisy. There was maybe some mesh there. Now it's completely gone. So that's a risk that you're going to run. Looks like we've got part of that cap is attached here, so I need to delete that. All right, so what I'm going to do is, again, hold down Shift, and I have another scan that has this specific area, so if it got completely removed, it's not the end of the world. Hit delete and hit OK. All right, so now we have 3 scans, and we want to merge them together. So what we need to do is we need to go to Process and Alignment. So the alignment can happen at the point level. There's only 3 scans that we've gone through and taken the raw data and fused it, so there are only 3 available here. If we say Automatic and Align, Creality will go through and try to find features on the parts and do its own alignment. And in most cases, if you have enough scan data, this actually works pretty well. The issue that we're going to run into is this edge here. And the reason for that is because scan 2 was pretty low resolution and pretty noisy. So what you might find is you may want to go back and exit out of this. I'm going to just show scan 2. And I may want to clean up the edges. So you can see how noisy the edges are. Because we scanned part of this from 2 different orientations, what we could do is we could clean it up. And I'm going to just come through and kind of get rid of that section there. And I'm going to do the same thing over here. I'm just going to do it across the top, just as an example. And then we'll select all 3 and we'll go back to alignment. All right, so everything should still be aligned. I'm going to rerun it just because I removed some data just to make sure. And you can see it shifted because now it's missing a little bit of that up top. It happened to shift it to the right. If this happens, we can do a manual alignment. So we can, let's see, go ahead and orient them roughly the same. What I'm going to do is I'm going to pick, let's see, I'm going to hold down Shift and pick a point there. And maybe there. And maybe on, we generally don't want them to be on plane. So if there's another area where we've got, let's say here, where we can give it another plane, then we want to go ahead and do that. We'll say align. Now the downside to this is we can really only do 2 scans at a time. So scan 1 and 2, you can see that it didn't do a very good job. So auto align certainly worked better. I'm going to let it run again, see if we can get a better result. But just note that you do have to have enough data overlapping to be able to make that happen. So what we can do is we can come back to the point cloud here that we've created. And if we want to, we can't undo the delete right now, but if we want to, we can go back and refuse it. So we can go back to that raw data. I'm going to take this down just a little bit and apply it. And what this will do is it'll go back to the raw data and it'll overwrite what we did with that point cloud. And then it'll just essentially create a new one for us. So now if we look at the new one, we can see the edge is kind of what we had before, a little jagged. And now if we show all 3 of those, go back to process and align, we should have more data across the top and hopefully we get a better alignment this time. Yeah, so you can see that looks a bit better. So once we're happy with it, with the alignment, we can exit. And now what we have is those 3 that are aligned together. Now they're not merged together, they're just in the right location. And this is slightly different than how Creality Scan 3 handled this. Creality Scan 3 actually put them as a combined unit together up here. So what we're going to do is we're going to mesh them. And mesh smoothing, it's just something that you kind of have to play with, but I don't want to use any boundary smoothing. We have to give it a target number of triangles. We can do sort of the one-click processing if you want. Remove isolated parts and remove spikes. I'm going to say low, and simply because we have those spikes on the edge of the border. The boundary smoothing, I'm going to just turn that to low, and mesh smoothing to low. Fill small holes, I'm going to turn off, and then we'll apply. And what this should allow us to do is take all 3 of those point clouds and turn them into a single mesh. All right, so when we look at the results, we can see there's obviously some areas missing here. You can see that. We've got some potential problems. So what this tells me is that the mesh settings were not quite good enough. However, the main thing that we need for this is we need the backside of that and the backside of that. So I'm going to go back so you can see the meshes down here. We're going to go to this mesh right here. What we're going to do is we're going to hide that. I'm going to go back to scan 1, 2, and 3. And we're going to process them again. All right, so instead of doing the mesh smoothing and boundary smoothing, I'm going to leave all those off. I'm going to allow it to fill small holes. And I'm going to increase the number of triangles just slightly and apply it and see if we can get a better result that keeps that section filled in. So even with doing up to 4 million triangles, we're still missing some information on the backside. And what I would attribute this to is scanning the backside on 0.5 millimeter resolution and not knowing when we got to the point where we had small enough points next to each other. So even though we did the fusing of that, so the best thing I could say is probably go back to that second scan, back to the raw data, and back to the fusion, and see if we can fuse this smaller. So I know we didn't get down to 0.1, but try to get down to 0.2 and see if we can generate a point cloud with that tight enough resolution. Because we have such a difference between the first scan and the third scan being at 0.1 and the back being at 0.5, I think that's why we're seeing some holes in the mesh on the backside, even up to 4 million triangles. It just isn't able to fill in those missing points. So hopefully the scan had enough data to do that resolution a little bit smaller, and that'll give us a good mesh result. So that looks pretty good. I'm gonna go ahead and go through the process of realigning these. It's gonna be the same as we did already, and then turn it into a mesh, and then we'll take a look. So it looks like actually they're already aligned. So I don't even need to worry about that. I can just go ahead and turn it right into a mesh. I'll still do 2 million triangles. I'll let it fill small holes, but leave everything else off, and then we'll see what that mesh looks like. Okay, so we can see now that it's filled in that area. So really it seems like the big thing was that during the fusion process, the mesh point spacing was just too far. So what this tells me is that in reality, I probably should have just scanned the backside on that 0.1 resolution, so I had a good idea as to when it all turned blue, because you can see missing a little bit of data there, missing some there, and missing some on this side. Now, as I mentioned in the video where we were scanning, I had already done all of this, recorded it. I actually have got the 3D printed parts sitting next to me right now. So when we get into Quick Surface, we will actually have different scans to work with. But since you can only watch this and not follow along, that's not a big deal. But just thought I would mention it, that I do have a better scan, a better version of this, where I did the back on 0.1 resolution. I did all 3 scans the same, but I just did the back on that lower resolution. Now we can take a look at some of our other scans. We've got the headlight. So we did this one with kind of the front and the top. And then this one here, we did the back. Now this was done on NIR mode, and it was done with medium. So we can see the preview on the screen is pretty big blocks. And then if we take a look at scan 6, this was NIR mode on medium, just getting the top. And then scan 7 was the bumper without, and scan 8 was the bumper with. Because the process is so similar for all of these, I'm just going to go through the bumper, the 2 bumper scans rather than go through the headlight, because again, it's going to be the same whether or not you're using small, medium, or large mode. You still have to go back and fuse the points together. So the resolution again is going to depend on your settings. 0.3 is as small as we can go because I want to get as much detail out of the bezel and the bumper as possible. I'm going to use that smallest value. Keep in mind the difference between, say, like a 0.1 or even 0.05 resolution on a laser scan. 0.3 is going to be probably the smallest we get when we're doing an NIR large mode. That number will be smaller if we do medium or small NIR mode, but it won't ever get down as small as you can with the cross laser line. All right, so here's the results of fusing the raw data into points. You can see there's some kind of floating stuff there. This is basically reflections off of the light, most likely. And we got some kind of stuff there as well. What we can do is we can try to turn this into a mesh. And there is remove isolated parts. So this is going to be a percentage of the overall size. So basically any isolated part that's not connected, we can remove. So let's say maybe 6.5% and allow it to process. Now 1 million triangles, smaller than we used on the bezel. That's okay because this is a much larger point distance, which means that we are not going to be able to capture the finer details. We will still be able to capture details like where the bezel meets and so on, but we don't need nearly as many triangles for big, broad surfaces like this. All right, so we can see that it was able to remove those sort of floating pieces because they weren't connected. There's still a little bit over here. Could possibly process that out in Quick Surface, but the problem is it's connected right there in that corner. But hopefully you get the idea. Let's go ahead and take a look. So we've got this one with the light, and then we've got the one without the light. So we'll go ahead and just process the one without the light. Larger setting. I want to do it a bit smaller because I hopefully want to pick up those mounting points. All right, so this one we got a little bit of the floor. Looks like we've got the mounting points, and it's connected there, so that's good because these two right here are mounting points, and that's a mounting point. So we would want to take this to a mesh, and triangles should be fine. Remove isolated parts. That should take care of the floor, and we'll just turn this one into a mesh as well. So again, the basic process of doing this for all the parts is very similar. The kind of decisions that you need to make are going to be at the fusing stage, how close you want the points in the point cloud to be. And my general idea is to make those as dense as possible, but that does come at a price. Generally, the more dense that point cloud is, the more noise that we have. It kind of looks like orange peel paint that just is not quite smooth. And we can process that out later. There are some smoothing tools, like we've got some mesh smoothing here in Creality Scan. Generally, what I do is I kind of work on that more so in other programs like Quick Surface. The ground here, we could keep this if we wanted to use it as a ground plane in Quick Surface, or we could just select and delete it if we wanted to. That's perfectly fine. But once we have all these meshes, so this is good because this gives us not only the areas that we need to watch out for designing these parts, it also kind of gives us where the back metal piece is. This is below the battery box, and it is a bit rusted. So there is, some of it's kind of rusted and missing, but for something like this, if you're designing an intake like this for, let's say, a race car, you would likely cut out some of that metal anyways. But it's a good idea to see where things are on the car. So we got a little bit of that. But from here, the next step would be to export these. So what we would do is we would, like for example, this mesh here, we would export the model. And we would pick STL, OBJ, PLY. In many cases, I just pick STL, mainly because the STL itself is a triangle mesh. And with the STL, it doesn't really need to be anything else. OBJ is what you would use if you were doing, let's say, a color scan and you wanted to capture and take that color data. One thing I have noticed with this update for Creality Scan is that there's only a single mesh at the bottom. So each time we generate a mesh, it seems to be like we've only got one mesh at the very bottom. So what I would say is that we create the mesh, export it, and then we would go back and say, show these three scans, generate a mesh from them, export it, and so on. I'll have to do a bit more playing around with Creality Scan 4 to see if that is truly the case. But from my initial impressions of it, it seems like that's the case where you only get a single mesh at the bottom of the entire project. Now, in most cases, when you scan a project, it's going to be, for example, it would be a project of just the bezel. And that's typically how it works. What I did in this case is I actually scanned the bezel, I scanned the light, I scanned the bumper without the parts, I scanned the bumper with the parts. And I don't think that's generally a common workflow. So that may be why Creality Scan just has the single mesh. That wasn't the case for Creality Scan version 3. I was able to generate multiple meshes. So just something to keep in mind, that it seems like that's maybe a potential limitation with this new version based on a single project here. Just something to keep in mind. So I'm going to go ahead and regenerate each of these meshes and export them. As I mentioned earlier on in the video, the stuff that we're going to see inside of Quick Surface and Fusion, those were the meshes that I scanned and created last week when I forgot to record the audio. So they're going to look slightly different from what we have here, but we still recorded the same thing. We got the bumper without anything in it, the bumper with everything in it. We've got the bezel by itself, the light by itself, and we're going to align those in Quick Surface so that they're all aligned to the same coordinate system, and then we can export them to Fusion and use them to begin our design process. So that's where we're going to end this video. So if you have any questions on anything you saw from scanning to processing, then please let me know. If you are in the market for a Creality scanner, then we are an affiliate. I'll leave a link in the description and you can use that link. It will help support the channel. If you have any questions on the Raptor Pro or any of the other scanners, I'll do my best to answer that question in the comments section. So as always, thanks for watching and we'll see you in the next one.